Welcome folks to lecture 4 of unit 3, and today's lecture will be relatively brief. We're just going to do a brief introduction to pressure and the gas laws, leading into our first gas law lab, which will be Boyle's law, hence the title and picture that you see. So what are our goals for today? Well, what we want to be able to do are three things. We want to be able to explain pressure as a physical property. We want to identify the units used to express pressure as that physical property, and we want to be able to explain how pressure influences phase changes, since that's what this whole unit is about. So first of all, we have to start with, well, what is pressure? Well, as a lot of other things that we've been doing here, it's a physical property of matter that involves gases and liquids, and in this case it's going to deal with collisions. Now, in the last lecture you had looked at diffusion and the way that particles move about and how they collide with one another. Well, in the case of pressure here, we're still doing that same thing, but not only are they colliding with each other, but they're also colliding with the container that they're in. And if you look at the graphic over on the right hand side, you have helium atoms that are bouncing about, colliding with one another, exerting pressure, but they're also colliding with the container that they are in, which is in this case the balloon. The pressure of the outside is caused by the particles of air that are bouncing or colliding with the balloon itself. And those collisions, whether they're on the inside or the outside of the balloon, cause a force. And the more energy we have, the faster the particles move. The more collisions we have, the higher pressure. The less energy, the less collisions, the lower the amount of pressure we're going to have. So essentially we're just measuring particles bouncing off one another and causing forces. So how do we measure that pressure? Well, since it is a physical property, it is something that we measure, and it's measured using either a barometer or a pressure gauge. Now, a barometer you may have heard of if you've watched the weather and they talk about the barometer rising or falling, and that has to do with atmospheric pressure, and that goes in part with weather. But more commonly, you might have come in contact with pressure gauges if you're blowing up a bike tire or a basketball or a football or any type of inflatable ball. You know exactly how much air pressure there is based on the gauge, and you see an example of that over on the right. Now, the units that we use, since it is a physical property, depends on what we're measuring. Now, the first unit, atmospheres, that tends to be used for atmospheric pressure, so if we're talking about pressure of the air. We also at times use mmHg, which stands for millimeters of mercury. That also was used for units of atmospheric pressure when barometers were made of large columns of mercury, and I'll explain that a little bit more in class. Kilopascals is mainly used in laboratories to express pressure of gases or fluids, but the more common one, the one that you're most familiar with, is the PSI, which stands for pounds per square inch. So we're measuring the pressure of the gas or the air that might be in an inflatable ball or a bike tire. Now, the units that you see down at the bottom are what we refer to as standard atmospheric pressure, the force that air causes at standard temperature, which is about 25 degrees Celsius at sea level. So when we look at all of these units of 1 atmosphere, 101.3 kilopascals, 760 millimeters of mercury, 14.7 psi, all of those are pressures in their respective units at sea level, at standard atmospheric pressure, and they're all equal to one another. So we could say 1 atmosphere is not just equal to 101.3 kilopascals, but it's also equal to 760 millimeters of mercury and 14.7 psi's, and we'll talk about in class how we can convert and how we can use those units. Well, we know what time it is right now. It's our brain break time, so why don't you get up from the computer and maybe run a mile or two, get the blood flowing. And today's Chuck Norris fact of the day: Chuck Norris doesn't cheat death, he wins fair and square. Moving on here. So, what are the effects of pressure on phase changes? Since we're talking about fluids and the way that gases and liquids interact, we can actually influence those phase changes by using pressure. Now, the first one, liquefaction, when we have something melt, most substances, it slows down the process, or it retards the process. So if we increase the pressure on a solid, it increases the melting point. We might need to heat it to a much higher temperature in order to get it to melt. Water, on the other hand, since it is anomalous, becomes easier to melt, and an increased pressure actually lowers the melting point. So if you want to liquefy ice, then all you have to do is increase the pressure on there. But more importantly, looking at vaporization. And vaporization, remember, is when a liquid converts into a vapor. And we already know a little bit about that. And not only do liquids have to overcome attractive forces, but they also have to overcome atmospheric pressure. So what happens if we change the pressure on that fluid? Well, if we decrease the pressure of a gas, we can lower the boiling points because there's less downward pressure on the surface. So if you have water in a decreased pressure system, you can actually boil water at a much lower temperature. On the other hand, if we increase the pressure, we increase the boiling point because now there's more downward pressure on the surface, and those water particles need to have more energy in order to be able to escape into the vapor phase. So the last thing we want to look at here, and we're going to finish up today, has to do with the gas laws. And they were developed to explain the relationship of pressure, volume, and temperature on one another of an ideal gas. And an ideal gas is what is composed of randomly moving particles. Now, when we look at these gas laws, we're assuming a few things. First of all, that we have a fixed amount of gas, that we're not changing the amount of gas. But the other conditions that we look at, pressure, volume, and temperature, two of them are going to be changing condition. One is going to be held constant, and the different gas laws that we're going to be doing in class will explain that. One thing we want to keep in mind is that temperature is measured in Kelvin, because remember, Kelvin is the only absolute scale of particle movement based on absolute zero. So if our temperature is in degrees Celsius, we need to convert to Kelvin. If you're not sure how to convert to Kelvin, go back and look at your notes. It's a very easy way to be able to convert from one unit to another. Okay, folks, so right here we're going to end, and as I said, we kept this one pretty brief, and we'll talk a little bit more about things in the next class, and we'll get more into the different gas laws. So we'll see you soon.